Okay, let's look at this question. How do I simplify an expression by combining like terms with variables in them? And the first thing I want to do is look at what a term is. We talked about what a term is. If you don't know what a term is, go back to my terms definition video, look over that again, get well versed before you move on to this video. Also, if you don't know the parts of a term, I would like you to go back to my parts of a basic term video and check that out first before we move on. Now, what does it mean to simplify? Well, let's look at an expression that we're all familiar with. Um, or I'll put it this way. Let's say you have a little cousin and you're like, hey, little buddy, how old are you? And he says, your little cousin is like, I am 2 squared plus 3 years old, right? He's like 2 squared plus 3 years old. And you're like thinking to yourself, oh, you little rascal, you are being tricky. And you're trying to tell me that you are 7 years old. You're 7 years old. So would you would look at this expression and go, that's not a very simple expression. And then you look at this expression and you're like, that's simple. I understand seven. But if that little guy tells me that he's 2 squared plus 3 years old, he's just being a smarty pants and he's giving you a complicated way of saying the number seven. So what we do is, because there's an operator here, we add this guy and this guy together to get seven. So we're combining these terms in order to simplify this expression here. Does that make sense? Okay. Now let's look at these like terms with variables. Let's look at these like terms with variables, right? And let's look at it. How do we combine them? Those didn't have any variables at all, the last expression. So let's look and see how we combine like terms. And so mathisfun.com says like terms. Now look, we haven't talked about exponents yet. So I don't really care about that part of the definition. We're not dealing with exponents. The only thing I would like you to see is this. Like terms are terms whose variables are the same. So if you have two terms and the variables are the same, they are like terms. Okay, going back. Okay, the question is, how do I simplify an expression by combining like terms with variables in? And I'm going to give you the quick answer. Here's the quick answer first. Okay, the quick answer says, what we're going to do is we're going to add coefficients. And add coefficients and attach, I'll put that in quotes, variable. All right. What does that mean? And why do we care about doing this? And how is this related to life? Anyways, Mr. Moore, let me give you an expression first. I'm going to give you the expression. Let me do it. Let me do it in black. Ta-da. Okay. And I'm going to give you an expression. 30, 30x plus, let me do it over here. I'm sorry. Ah, okay. 30x plus, or it's actually 3/10x or 30 hundredths x, and then here is 10 hundredths x. Okay. Oh, come on, Mr. Moore. This gobbledygook. This doesn't mean anything. These are just like weird It's just some weird expression that I'm probably never going to use. Well, maybe not. But let's put some context to this. Let's put some context to this. And let's just say that we're starting a lemonade stand and we're trying to figure out all the costs for 1 cup of lemonade, right? And right here, this 0.3, maybe that's the cost per cup for lemons. So I'm going to put lemons, right? Per cup, right? So I look at this and I say, and erase that. I'm going to erase the X, and instead I'm going to put in I'm going to say, well, how much does it cost if I sell 3 cups, right? So I replace the X with a 3, right? Because X equals number of cups. Okay. So if I sell 3 cups, that costs me in lemons 90 cents, right? About 10 cups. How much did 10 cups cost me? Well, that's now $3. So in order to sell 10 cups, I have to spend $3 on lemons, right? And so remember when we played these what if scenarios to make predictions with these expressions? Well, that's what we're doing again. Except this time it's for a lemonade stand. Oops. So I'm going to put the X here. Now, let's look at this other scenario. Let's just say this is the straw per cup. So you're going to use 1 straw per cup, and I guess the straw is, so you're going to use 10 cents, so 10 cents per cup in straws, right? So if I sell 3 cups, that costs me 30 cents, right? And if I sell 10 cups, well, that's $1. So it costs me $1 in straws when I sell 10 cups. Now, imagine this. I'm going to put X back because, okay. Now imagine, do you want to, every time you, let's say you sell 100 cups, do you want to individually calculate the cost of lemons, calculate the cost of straws, calculate the cost of all the other things separately? Or would you rather add these 2 expressions together? I'm talking about these 2 expressions. Add these 2 expressions together, and that'll tell me how much it costs for both lemons and straws. In fact, I can total up all the expenses into a nice, neat number or nice, neat expression right here. So, So what we're going to do is we're going to combine these like terms. Are they like? Yes. Remember our definition? Let's go back to our definition. It said that if the variables are the same, we get to add the coefficients together and attach a variable. In this case, the variable is X. So adding the 2 together, 30 cents, right? 30 cents and 10 cents is going to give us 40 cents. So that's for lemons and strawberries. That's going to be 40 cents per cup. And now I don't have to make 2 separate calculations. I only have to make, boom, 1 calculation to calculate my cost. So that's why it's important to be able to add like terms together with variables in them. It's useful. Okay, let's go over another example. Let's go over another example, just a quickie example, and then I should be able to end this video. Okay. Again, if I have decimal, or no, let's just do this, 3x plus 4x. That's even easier. Now, I'm not going to put a concept to these numbers, right? I'm not sure what these represent, but the idea is to get you to understand that when you have like terms, for example, same variable, good job. If they're the same variable, then we get to add the coefficients together. 3 and 4 is 7. And attach the variable. In this case, the like variable is x, so I just attach the variable. And now I have 7x. So 3x plus 4x is 7x. There is a special rule in math that allows us to do this. And when we talk about factoring later on, we'll go into that rule more in depth. Well, what we've done is we've simplified an expression. This is our expression here. We've simplified this expression by combining like terms, and both terms had variables. I hope this helped clear things up for you. Have a great day.